Okay, welcome Devoxx. Today we're going to have a quick talk, 30 minutes about JMH. My name is Tom Vleminckx. I work for a company called FIS. Formerly it was Clear to Pay. And I have some technical issues. Yep, okay, now we're in the game. So who am I? I'm a technical architect and I'm a lead for a team of architects which work on the, let's say, the ground of the core layers of a payment execution engine. We also do some R&D work in the same area. Well, our group and me in particular also, we have a special interest in performance tuning, monitoring, operational intelligence. So that's a bit the reason why today I come and talk about micro benchmarking, because it falls immediately into one of these topics. So what's the agenda for now? We quickly have some reasoning about why you should write benchmarks. And then we immediately jump to a nice way to do these benchmarks, and that's by using an OpenJDK tool called JMH. We'll go through a cycle of writing a benchmark, running it, seeing to which extent we can leverage profilers, and we look at the reporting capabilities. And then, depending on the timing, I will give a bunch of examples, and I give you some pointers if you want to start using these kind of techniques. So first, most important maybe, why should you do some benchmarking? Now, it's the same question as why should I do unit testing? So the answer to these questions, you all know them. In case of benchmarking, what is important if you run systems where performance is important and where certain algorithms or certain key components are being developed by big groups of people that are very sensitive to performance, then it might be a very good idea to pin down or to baseline their performance characteristics. And of course, how do you pin them down? You write benchmarks. What you also want to do is you want to fail early. Just like with unit tests, they run very early in the cycle of delivering your software, your benchmarks also. So if you have a problem, if you see that you're not hitting your baseline, you have a huge regression, you can fail your build, you know it early. You don't want to go to the full deployment of a very complex system, maybe depending on what sort of company or customer you're working for, that might take a week or a month or even 6 months before you know that you have a problem. What is for me even more important is it is a way to anticipate or reproduce issues. So micro benchmarking, what we're going to talk about, is also trying to zero in on problems in the best way you can. And if we're in the performance-related field, a lot of issues might occur when a lot of stress is on the system. And so the idea is put as much stress on the system as you physically can with the least resources you have. So if you then can isolate on a very small component or algorithm and put all the cores you have and throw them at hammering that component, more stress means more chance to get lucky or unlucky, depending on how you want to see it. What I mean is more chance that you hit an issue, or more chance that you, when you don't have an issue, that there is actually not an issue. For example, if you're looking at synchronizations issues, race conditions, these kind of things, if you're in a very big complex system with hundreds of users on it, and you want to hammer that system, you need a lot of virtual users. And then you go to gmeter, you go to Gatlin, and the Grinder, and there are a bunch of other alternatives. But then you're always attacking the system from the outside, and it takes a lot of virtual users to maybe hammer that particular component in that particular condition so that you have that race condition. Imagine you get those nice null pointer exceptions in production once every month, but you still want to know where they come from. You have an ID. Well, maybe it's a good idea to write a micro benchmark on them and hammer that subsystem. Of course, you can also use it to qualify your system. In our case, we have to ship systems to financial institutions, and we sell those systems with an SLA. We have to be able to produce that many, execute that many payments in that amount of time. For example, 100 payments per core per second. That means also that we have to test for these cases. Of course, we do our system tests, but we also would like to maybe zoom in on very small parts and baseline them. And also prove to our customer that certain changes we did, that they actually make sense and that we're not introducing some regressions. Also, it's easy during code reviews, you all have a colleague that's a good friend, but you don't trust his code. And in those cases, sometimes behind his back, or maybe to educate him, that's the next step, just write a small benchmark and see what he claims is actually the truth. Now, of course, benchmarks are not exactly the same as unit tests, so I was wrong in the introduction of these slides. Here you don't have absolute proof. But for example, for a race condition, maybe I have to hammer the system even more, but at least I get some sentiment, I get a feeling, and that makes me sleep better at night. Other things might also help to sleep better, so don't only do benchmarks. Now, benchmarking, I must admit, is very hard. So in the past, I had to do it multiple times for previous customers of mine. And what I did, always the same thing. You start writing your own multi-threaded benchmark where you do everything from scratch. You write some tests, you try to balance them to create some situation, and basically you lose a lot of time and you make mistakes. I make mistakes because my brain has a limited capacity. I have not all the knowledge. Things that are difficult is multi-threading, always difficult. Those who say that it's not difficult, well, come and talk to me after the talk, because that maybe you're a genius and you should work for us. The Java memory model, it's pretty complex. You need deep knowledge of it. The way to measure time, it's not always easy to do that. There are some theories about it. Not everybody is aware of it. Basic things like calculating percentiles, statistics of results, you can dump them in Excel, of course, but do you want to do that yourself? Also, you're fighting against how the CPU behaves and how the JIT compiler in Java behaves. Some examples, look them up if you want to know exactly what they mean, or ask it during the Q&A. Loop unrolling, constant folding, inlining of methods, false sharing, which is a very, very nasty one. So if you know all of that, should you write your own framework? Now, I will say no, don't do that. If you really don't know and you can't sleep good at night, as we already said, maybe you should, but use something that is readily available. What is readily available for you? JMH, the Java Micro Benchmark Harness, it's part of the OpenJDK. Now, there are other tools. In the past, I think it was Google had a tool called Caliper. It is also very well seen in the community, but this is, let's say, the more fresh kid on the block. You see this appearing also more and more in open source projects where people start applying these kind of things. And I have to stand still for a second. I heard that from the other guys doing talks, so I just listen. You see more and more these JMH tests appear in open source projects. So maybe one day you want to contribute and you hit one of these tests. Well, after this presentation, I hope you can see in which area they belong and why you should care about them. So it's a toolkit, Java Micro Benchmark. Now, it's not only for micro benchmarks. I use it for benchmarks that that are not zeroing in on the millisecond or zeroing in on just one method. I've used them really to do bigger components, and with success. That doesn't say that it is always applicable to these levels. It also depends a bit on the level of isolation you can bring into your tests. If the micro should not become a whole application with a database, networking, an LDAP, and so on. No, you still want a very well isolated system. You don't want to introduce mocks, or maybe you want, but let's look at just above the level of a method and a subcomponent would be okay. The toolkit helps you to write, run, profile, and report on these benchmarks. And basically, it's very, very simple to use. All the hard stuff that we talked about, all these optimizations that the JIT compiler do, all this funky stuff that the CPU can do, these things are abstracted away, and you end up with an API that is very similar to JUnit. So it's annotation-based. Now, to set up such a test, if you want to write such a test, you can go the Maven way or you can go the Gradle way. Now, I went the Gradle way for this presentation because we work in a Gradle shop, and also because it does a few steps in one go. Now, you can go with Maven, but then you have to do it in 2 steps. You first have to build your benchmark, and then you have to separately run it as a Java application, while Gradle does all of that for you. Now, multiple JVM languages are supported, so you can do this for example, Scala too. So not only Java. I will give some pointers to the documentation later, so you can look that up. Now, the structure, you see to the, and I have to think about left and right. Sorry, sometimes people get nervous. So on the right of the slide, you see a typical layout of a Maven or a Gradle-based project, and where you have a main with Java sources and a test for your unit test. You have a JMH folder where there you have your Java JMH tests. So as I said, it's annotation-based, and the most simple benchmark I can write here is also to the right, a simple bench method annotated with benchmark. So this is what is going to be executed. And I can do, if I want, a setup and a tear down if I have some state to set up or clear. So, of course, I don't want to measure here just that single method. I want to measure that in a certain setup. So I'm going to quickly jump a bit further. So when I want to run this, I will parameterize this. And I will say, OK, I want to run this particular method for a particular time, and I want to measure how many executions, for example, I can do per second. I can do that for a number of threads, and I can do that a few iterations, and I can also do a warm-up. Why is a warm-up so important? You all know that Java Virtual Machine starts to optimize code on the go, so the just-in-time compiler plays a role, and we're going to look at this later, that effect. You can also measure average time, so you could say this one bench method, how long does this take? Now, in my case, I've always been more interested in the number of executions I could do per second, but that's just because of my use cases. You can also do a single shot, so just measure one execution, and you can also go for percentiles. So, for example, 90% of all executions takes less than 10 milliseconds, for example. So, before we jump into an example, a few guidelines. So, there are hard things in writing that performance test, that benchmark test. Most of them are abstracted away, but there is one thing you absolutely need to know is that you want to use either a black hole or a return statement. I will explain. So in this example, in my bench method, I actually return the result of my calculation. If I would not do that, I might end up with the JIT compiler being smarter than me and saying, look, you're doing something which has no impact, I will just factor it away. And what I will be measuring is an empty method. What behind the scenes this framework will do is it will pick up this result and it will make sure that the JIT compiler understands that this is not throwaway stuff, that it actually matters, and so it will not be optimized away. If you have similar things happening in your code, but not at a place where you can do a return, you can use a black hole object to do the same stuff. So that's actually the only thing I would say that you need to care for yourself. There are a few others, but I would suggest look at the documentation. So I'm going to give you a first example. Now, the example that I wrote here is, okay, it's an example. It's maybe a bit a stupid example, but what I have here is two methods. I have bench 1 and 2. In one case, I just do a split on a string, and in the other case, I use a pattern, so a regular expression to do that split on a string. Now, this is not a quiz. I'm just going to give directly away the right answer. Which one should you use? Of course, you should use the pattern because it's pre-compiled. And if you look in the implementation of string.split in Java, that internally every time creates a new regular expression, so it's far less optimal. Now, if I run this test, the framework will here first do a warm-up phase, and then then the results will become available. And see, he's at his first iteration, and he already has an idea of the number of operations per second that happened. So there are 2 samples for the first benchmark, and there will be 2 samples for the second one, because I've configured it like that. So. And the end result is I get around 1.2 million executions per second on the, let's say, suboptimal implementation, and on the more optimal implementation, I got 1.8 million executions per second. So, first example. So, this leads us to the next step. Of course, it was a bit of a black box what I was doing. So I just got the result, but let's say that the result is not what I would expect it to be, or that I want some insight. Now, you can very easily profile these things, and with profiling, I don't mean take your kit or your G-profiler or whatever other profiler that you might have lying around and hook into this. That's definitely possible, but the first step is that you profile while running and by means of the built-in profilers. Now you have multiple built-in profilers, and they also depend a bit on the operating system you're on. Now, one of the very interesting ones is the stack profiler. It allows you to do stack sampling while you're running your benchmark, and it will give you an overview of what are the most used methods and what are the methods longest on the stack. And it gives you also an idea of the thread state. And that's very interesting, that thread state, because that's immediately often linked to concurrency problems. Blocks that happen due to suboptimal usage of synchronization, for example. And another one that is very interesting is the profiler that looks at the JIT compiler. It basically just looks at some statistics that are readily available over JMH in your GVM. Now, if I would combine these two, and I got a small example for that. So I got here another benchmark test. And in this test, I always want to point at the screen. In this test, what I do is I have a map, and I try to constantly put something in the map if it's not contained in there. What I basically do is I put the thread ID in there. Now, I know I use a map, and I use it from multiple threads, so, well, I will synchronize on the map, so I'm safe. Now, if I run this code, so profiler, I've configured it also to run with the profiler being active. I'll show that later on how to do that. And I start looking at my answers. So this is a bit a problem. I have to run these, and they take a bit of time. Okay, I will try. Okay, I should reuse the text font, I guess. Okay, is this better? Okay, sorry about that. So what you see in this example is that I have my test running, and I have a certain score of the number of executions. But if I look at the version where I do the synchronization, I immediately see that 70% of the time, my threads are blocked. So they're actually waiting on that synchronization, and they're not actually running. So, and 100% of these blocked threads, they're all in that do something method. So what is really interesting about this, although this is functionally correct code, you see if you throw this into your application, you're making a bottleneck. Now, if this would be in a library deep down, then this bottleneck would only be seen if you have really a lot of execution going on in your application. And that problem might only occur in a big production system. And you would not see that if you're doing some simple testing. And by here, zeroing in on that simple block of code, you have much more chance to have this synchronization bottleneck. So it's really interesting to be able to do that with these profilers. Now something else that you might notice here, for every run, I get a result here of the time that was spent in the JIT compiler. Now I have a warm-up, and then later on I have my first iteration. Now the results that I get now, they're not reliable. Why? Because the JIT compiler is still busy optimizing my code. So it might be that the results that I would get when I actually run this in my production environment would be better because the JIT compiler can throw even more knowledge at it. So ideally, I would now make the duration of my test longer, do a few more additional iterations until I hit that sweet spot where there is no more JIT compiling. And then I know that I have the actual, let's say, more realistic result. So these are two examples of what you can do with the profilers. Now, there are other profilers that can be hooked up. For example, you can look at the GC. You can look at class loader stats. So if you're doing some funky stuff with class for name and maybe doing your own class loaders, it might be a good idea to look at how many classes that you're loading and how many classes that get garbage collected. So all interesting stuff. Another thing is these profilers are available, especially on Linux machines, to go to the level of the compiled native code. So whatever the JIT optimize. So if you're really deep into performance, you can even get these details out. On my MacBook, this is not possible, and it would also be maybe a bit over the top for this session, doing that kind of stuff. So next step, I already talked about the report. So what you've seen until now is the human readable report. Of course, that's for the people that need to analyze this. You can also have the report in a machine interpretable way, a comma-separated file, a JSON file, or whatever you want. And that's something that you typically can use in your CI environments, continuous integration. And you can there then maybe potentially fail the build if you have a regression on a certain test. I got an example of that also, setting it up in a Jenkins. So if you have some time, I will go there. Now, I showed you very basic tests. What you can also do, and I find that a very elegant way to do this, if you have to reproduce a concurrency problem, or if you have to see how well a certain algorithm behaves depending on the nature, or a component, sorry, on the nature of what you throw at it. For example, something that does reads and writes. Basically, if you do a lot of reads and not a lot of writes, often you choose for a certain type of collection or synchronization. If you do a lot of writes and only a few reads, you might need to do something completely different. And in this case, reproducing this can be done by combining benchmarks. So in the example here, I have two benchmarks methods, a consume and a produce, and I group them together by making them part of my consume-produce group. And then I balance them out, and I say, okay, from all the threads I have available, 3 out of 4 go into the consume, and 1 out of 4 go into the produce. Immediately, you can see what is the use of this type of construct. You immediately see that by iterating a bit and playing with these parameters, you can have quite a different set of benchmark, and you can zero in on different aspects of your algorithm. So I find this a very, very neat way of doing it. If you would not do this and you had to write it by hand, okay, you make 2 pools and you launch in one pool one type of code and in the other another type. You can do that by yourself, but this is just so easy. Another way, and that's also interesting, is you can reuse benchmarks. So if you write a benchmark and you want variations of this benchmark, you can use the add param annotation. In this case, my benchmark will be executed for the param 1, 2, and 3. So I get 3 results in my results. So if you have, for example, an algorithm where you want to maybe load some a bench where you want to load some property files that configure it, this might be a good way to implement it. So before I go to the last examples, before I run out of time, if you want to know more about this, so have a look at the JMH website. It's part of the OpenJDK. They have very, very good examples. They have around 30 examples that very well show the different constructs that you have, the different annotations, but also show those different hard problems they solve. They simulate stuff like inlining and false sharing, and if you want to be educated on these topics, I find it amazing, their examples. And of course, if you like my examples, which are far less impressive, you can go to my GitHub. I will tweet the addresses if you want also, so you don't have to all take pictures. We have some additional time for some questions. If there are no questions, I would like to thank you all for being here and attending this talk. I hope you got something from it. If there are no questions, I still have 1 or 2 examples that I can show. So up to you guys. Examples? Okay, examples it will be. So what I didn't explain earlier on is, in my example here, this is the fact that I have a state annotation. And the state annotation allows me to construct shared or non-shared state between the different threads that I'm using. And in this case, the tokens here, these parameters, are part of they're at the level of the benchmark. If I would use another scope, I could use a scope, sorry, wrong keyboard. If, for example, I would say the scope is thread, then this would be isolated per thread. So that's an example. Now, something else that I can show is a concurrency issue waiting to happen. Of course, this again is code that is far from realistic, but this is a type of code that I sometimes stumble upon when I do code reviews. So one of your colleagues might have written something that removes something from a list and then adds it. And he says, 2 operations on a list in a multi-threaded environment, I'll synchronize the list. that will make sure everything is okay. And in the meantime, I also have here in my other bench of the same group, I'm just reading it out. If I run this bench, you will immediately see that I'll hit a concurrency issue. I should hit it if there is no Murphy in the room. Voila. I immediately have my problem. So probably in this case, pretty quickly, because I'm always hammering the same thing, but these kind of problems occur in production systems where they happen once every 5 months, then it's very, very interesting to try to write small tests that simulate these problems. Or these problems pop up while you're doing your first runs on a new component or library that you're doing. So I'm out of time, so I have to shut up. I would say thanks a lot for being here, for attending my talk. I'll make sure everything is available on Twitter. Yeah, thanks again.